Okay, hey everybody. If you're here, you're interested in the MSP430 Launchpad, and this will be my first tutorial on basically how to blink a light. I know that Texas Instruments does another tutorial, but this is just me my first, and hopefully a series of tutorials based off the MSP430 Launchpad, where I will go into clocks and interrupts and timers, and just kind of that kind of stuff. But I know I need to start with the basics, so here we go. So first we're going to start off, we're going to create a new project. So you create a new CCS project, and we're going to call it Tutorial 1B. Now I'm doing this live just because it's a lot less time consuming on my part, so hopefully it's not too crazy. So we've created our tutorial, and you just want to leave everything else here the same because your project type is MSP430, and so we'll hit next. We don't need to reference anything, so we wait, and okay. So when you come to this window, what you want to do is select your device variant. You're going to want to come over here and read off the chip, because I know the Launchpad comes with two different chips. I'm using the G2231 version, so just select in the drop down box the G2231 and leave everything else the same, and then click finish. Then we wait a little bit. Okay, so here we go over here. We're going to expand it, and the first you're going to want to do is make a new source file. So here we go. New source file. Oh. And okay, not sure why that took so long. Okay, so our new source file, I'm just going to call it source1.c, since this is a C-coded file. Okay, first I like to do is just put a little commenting saying this is tutorial 1 and it's January 26, 2011. Now you want to use the included file that is made for every MSP430, and that's just has the same name as the chip, so it's MSP430 G2231.h, and I'll show you where those are. To go look at it, you want to click your includes folder, which is automatically added, and it takes a second to open because there are lots of files in there. I haven't counted it, but there's over at least a couple hundred, and on my speedy machine it takes a sec to open it, but it's good to have open to reference back to all the commands. I had all this stuff pre-opened, but then I decided that it'd be easier to figure this out if I just went through every step. And I'm sorry it takes so long. Okay, so here we are with all the source files. So we're going to go down to MSP430 G2231. Oh, there it is, G2231. And we'll open that up. Okay, so now we've got the header file open. Now I'm going to close out this thing, so I don't need it anymore. So I'm just going to minimize that, minimize that. Okay, so now that we've included the source file, you're going to want to start with a main project, with a main, just main. I'm not a huge coder, so this is probably not going to be the most beautiful thing. Most beautiful. Now the first thing you want to do, because this is just an introductory project, is you're going to stop the watchdog timer. And you have to do this because the watchdog timer is just a safety thing where if you don't reset it actively, it'll reset your microcontroller. It's like a 16-bit counter, which counts to like the maximum number, and then if you don't reset it in that time, it'll reset the whole chip. Since we're just starting out, we're going to turn it off. So the control register for the watchdog timer is WDTCTL. Now I'm going to go into more detail on timers and how to set all this stuff up and what this stuff means later on. So as for now, just kind of follow along. Okay, next I want to change my timer so it only works at 1 megahertz. I want to change my overall CPU to just run at 1 megahertz to make the blinking light a little easier. So again, this stuff is just going to be more advanced to just start out with, but this is just basic setting it up. And I just want to talk about how you output and input we'll output on this one to start out with. This if statement is just used for, oh brother. This if statement is just used for setting up the clock, and if there's a fault, it'll just lock the MSP430 in this while loop, which will repeat forever. Now we're going to change the 2 clocks to run at 1 megahertz. Now some of these values I'm using are intrinsic, and but all these registers can be found in the header file, which I will be going into much more detail down the road. Okay, so now we got our clock set up good enough for this example. So now what we want to do is we want to make the light or the LED that's attached to port 1.6. If you look at the MSP430 itself, you can see that everything goes from 0 to 7 because there's 8 bits to a byte, obviously. So what you want to do is turn on the bit associated with port 1.6. Now, first you want to do is assign a direction to make 6 an output, and the command for that is P1 direction. It's just setting the direction of the port. Now, to figure out what you need that to make that equal to, I've got a little note here, which I've kind of written out. Now, these are the ports as that are associated with port 1. There's going to be 8 of them. I didn't draw the very last one. There's actually another 0 right here. Let's see here, 0. Okay, so I guess we're at 7 up here. 7. Not the most beautiful thing in the world. So what you want to do is make everything on here a 0 except 1, because that's going to be our only output. So what I like to do is I use a handy converter and just say, okay, I want to have 6 zeros, and my 7th one is going to be a 1. So we know that's hexadecimal 40. So you can see we have 6 zeros and our 7th is a 1. So we go back over here and we make that equal to hex 40. So that'll now make every port an input except port 6, which will make that an output. And we want to just assign everything on port 1 to output a 0 right now. So now we're going to set up our loop to just blink some lights. So first I'm going to do is just make a while loop, which repeats forever. While 1 is just while 1 exists, and so it's an infinite loop. So first thing we're going to want to do is set up a delay. Now there is an intrinsic command called delay cycles, which I don't like to use that often, but I want to be doing it now because that's kind of what TI does in their tutorial, so I'm kind of follow along. So the first thing we're going to do is just output a high. We're going to set P out to equal 0x40, which again is just a 1 high on port 6. And now we're going to delay. So we'll delay cycles, and we're going to delay 50,000. Because if we're running at 100 megahertz, you don't want it to, blink too fast. So then we're going to turn it off. We're going to go P out equals. I just realized that I'm kind of running over, but I'm not really used to doing this. This is my first go at this. Is 0. Okay, and we're going to delay again. $50,000. Okay, so we close that. Enter. And then we need to close our main. Enter. And hopefully I got everything right, and we'll see how it goes. So let's compile it. Save changes. Oh, dang, I have 3 errors. Oh, what did I do wrong? When you kind of do this stuff on the fly, you can get typos. CALDCO. Oh, there we are. 1 meg. That's supposed to be equals. I think that's supposed to be equals 0x f. Line 26, it says. Oh, right. Let's try it again. Alright, we have compilation. Now we'll compile, run, and go. There we go. You can see we are now blinking port 1.6 rapidly. Alright, and that ends this tutorial. So thanks for watching, and stay tuned for some things that are going to be more complex.